So let's say we have the sequence 4, 12, 24, and 40, and we want to find the equation for the quadratic relation that the sequence describes. So first of all, it's important to go over the fact that if we look at the first difference between each of these terms, we'll see that this one is 8, this one is 12, this one is 16, and so the first differences aren't consistent. But then if we look at the second differences, we'll notice that both of these equal 4. And so the second difference is consistent. And this is how we know that it's a quadratic relation. So what we want to do to find the equation is to find the values of a, b, and c in the general formula y equals ax squared plus bx plus c. And we can work from this general equation to sort of derive a few formulas that we can use that will always work in this context. So let's start by setting up a table of x and y values. So let's assume we're incrementing x by 1, and let's use 4 different terms. So if we were to substitute 1 as our x value into this equation, we would end up with a times 1 squared plus b times 1 plus c, which equals a plus b plus c. So our y term is a plus b plus c. And again, we just got this y value by substituting in to this general equation over here, the x value that we assigned in the table. Now, for 2, if we substitute 2 as our x value, we'll have y equals a times 2 squared plus b times 2 plus c. And this lands us with 4a plus 2b plus c. So this is our second term. And if we continue this for 3 and 4, so if we substitute 3 back into this equation, we're going to get 9a plus 3b plus c. And if we substitute 4 into that equation, we're going to get 16a plus 4b plus c. So now we have sort of a general sequence of terms that we can use to describe a quadratic relation. And now let's take a look at the first difference for this sequence. So I'm just going to erase these for the sake of space. So if we look at the first differences, we'll notice here that if we were to basically take, 4a plus 2b plus c, and we were to subtract a plus b plus c, so we're basically taking term 2, which you can see right here, and we're subtracting term 1 the same way that we would with these first differences up here, except we're using algebra this time. We will get 3a plus b. And so our first difference between these two terms, term 1 and term 2 here, is 3a plus b. If we repeat this process for the next two, we will get 5a plus b. And if we repeat the process here, we will get 7a plus b. And if we look at the second differences, here, the second difference is 2a. Notice that if you take 5a plus b and you subtract 3a plus b, you will end up with 2a, and that's how we get this value here. And between the last two, the second difference is also 2a. If you take 7a plus b and subtract 5a plus b, you will also get 2a. So the second differences are consistent while the first differences are not. And again, this lines up with our expectation for a quadratic relation. So the way that we can use this is that we can see that the second difference is equal to 2a. So we can use this as one of our first sort of equations that we can use. So 1, 2a equals second difference. And we can use that assumption to work backwards from the second difference if we have its value to solve for a. So now we can also see that the difference between the first two terms, we can call this u2 minus u1, where u2 is the second term and u1 is the first term. And we can tell that this difference has to be equal to 3a plus b, as we see here. So this is another assumption we can make. We can say that u2 minus u1 equals 3a plus b. And finally, we can also see that the first term here that we've described as u1, this is going to always be equal to a plus b plus c. Remember, we got this from substituting 1 in as our x value into this general equation right here. So the third assumption we can make is that u1, or the first term, will always equal a plus b plus c. And it's important to note that in these equations, we involve the variable a, then we involve b, and then we involve c. And we're going to want to use these sort of sequentially in order to determine the value of each of these variables. So let me erase this for the sake of space, and we can try this out with our example sequence. So if we look back at the sequence that we were dealing with at the beginning, 4, 12, 24, and 40, let's try to apply these equations. So we know that 2a is equal to the second difference. So what can we say from this? Well, we found the value of the second difference for this sequence. For this sequence, the second difference is equal to 4. So we can say that 2a equals 4. Then if you divide both sides by 2, a equals 4 over 2, which equals 2. So now we have the value for a in our general equation. So now that we have a, we can use equation 2, since we only have one unknown in this equation. So using equation 2, we can say that u2, the second term, minus u1, the first term, equals 3a plus b. And we know that a equals 2. And we know the value of the first and second terms of the sequence. So here we get that 12, the second term, minus 4, the first term, equals 3 times 2, our calculated value of a from over here, plus b. So we can say that 6 plus b, or I should put this on the other side, we can say that 8 equals 6 plus b. And so 8 minus 6 equals b. Sorry if these are confusing. This is a 6 and this is a b. So 2 equals b. So now we have the value for b and we have the value for a. So all that's left is c, and we can use equation 3 now since we only have one unknown. So equation 3 says that the first term needs to be equal to a plus b plus c. And we want to solve for c since we already know a and b and the value of the first term. So the value of the first term is equal to 4. And we know that a is equal to 2 and b is equal to 2. So we can say 4 equals 4 plus c, and if we subtract 4 from both sides, if we subtract 4 from both sides, we will get that c equals 0. So if we plug all of these values, these 3 values that we've just calculated, back into, back into our general equation for a quadratic up here, we get a final equation of y equals 2x squared plus 2x plus 0, or just y equals 2x squared plus 2x. And this is how you solve for the formula given any quadratic relation in the form of a sequence.